Hello everyone. Today we are going to discuss types of reactions based on number of steps. Chemical kinetics. The next topic what we are going to discuss. Types of reactions, chemical reactions based on what? Number of steps. Some reactions, some chemical reactions occur in single step. Some chemical reactions occur in single step. Some other chemical reactions occur in multiple steps. In two or more steps. In two or more steps, the reactions will take place. They are called what? Complex reactions. Complex reactions are the chemical reactions which occur in two or more steps. Okay, ma. And what is elementary reaction? Elementary reaction is the chemical reaction which occurs in, which completes in a single step. A single step reaction is called elementary reaction. Okay, and multiple step reaction is called complex reaction. So, how many types of chemical reactions we take here? Two types of chemical reactions. What are they? Elementary and what? Complex. Okay, elementary reactions and what? Complex reactions. Elementary reactions and complex reactions. Which reactions occur in a single step? So these elementary reactions occur in a single step. In a single step. Right? And the complex reactions occur in multiple steps. Occur in multiple steps. Okay? So means two or more steps will be there in complex reactions. But in elementary reactions, only single step will be there. Only single step will be present in. Only single step occurs in one of these elementary, and in complex reactions, two steps or more than two steps will be occur. Right now? And now here, in this case, in single step reactions, what we will take example, C plus O2 gives rise to CO2. C plus O2 gives rise to what? CO2 we can take. C plus O2 gives rise to CO2 is what now? Single step reaction. Example I am taking here. C plus O2 gives rise to what? CO2. It is single step reaction. In single step, the reaction completes. Is that clear now? Now, if you take multiple step reaction, in multiple step reaction, what happens is that, suppose you take dissociation of ozone. Dissociation of ozone. O3 will dissociate into O2 and O. O2 and O. Suppose what happens is that, so I am taking first step here. Suppose the example of complex reaction I am taking. In step 1, what happens is that ozone dissociates. Ozone, O3 molecule, dissociates into what? O2 and O. O is called here nascent oxygen. O is called what here? Nascent oxygen. What is the word here? N-A-S-C-E-N-T. Nascent oxygen. It is highly reactive. This nascent oxygen is what? Highly reactive, which is called newly born oxygen atom here. This oxygen is very reactive. That's why we have placed it within brackets. Okay, within parentheses, we have placed what? Nascent oxygen here. So O3 first dissociates into what? O2 and O. This nascent oxygen is highly reactive. Highly reactive species meaning what? Less stable or more stable? Very less stable. Less stable meaning what? Highly reactive. So this highly reactive intermediate species. The O is what? Nascent oxygen is what here? Highly reactive intermediate species. Reaction intermediate. In between the reactants and products, some intermediates are formed. I told now in mechanism. Mechanism of reaction is nothing but path of chemical reaction. Before the reactants are converted into products, between reactants and products, what will be formed? Reaction intermediates are formed. Okay, it is what now nascent oxygen acts as what here? Reaction intermediate. Reaction intermediate it is. So it is highly reactive species. This nascent oxygen will attack again one more O3 molecule. One more O3 molecule is attacked. Now I am writing step 2. Step 2 and in step 2, what happens is that One more ozone molecule. One more ozone molecule is attacked by what? Nascent oxygen. This nascent oxygen attacks what? Another O3 molecule. Another O3 molecule is attacked by what? This nascent oxygen. Is that clear? Now what happens is that again this O3 will dissociate into what? O2 and O. That O and O will combine. Again this O3 molecule will dissociate into O2 and O, right? That O and O, nascent oxygen and nascent oxygen will combine to form O2 again. That's why here from O3 one O2 is coming, and this nascent oxygen coming from O3 and this O nascent oxygen, both will combine to form another O2 molecule. Now how many O2 molecules will be formed here totally? Here 2 moles of O2 will be formed here. How many moles of oxygen is formed here? 2 moles of oxygen is formed. In second step, what happened? Tell me. In second step, O3 is attacked by nascent oxygen to form 2 O2. How many steps the reaction has completed? 2 steps. Now tell me what will be the overall reaction? What is the overall reaction of here? Overall reaction means what? These 2 reactions should be added. Okay, now what we have to do is that before adding the 2 equations, what we have to do, the common things, common species on opposite sides, we have to cancel. That is the common things of reactants of this, products of this. If any common things are there, we have to cancel. And common things of this products and this reactants. The products of first step, reactants of second step. If any common species are available, that should be cancelled. Okay, that is the addition of reactions. Before adding step 1, step 2. Before adding step 1, step 2, what we have to do, ma'am? We have to cancel this nascent oxygen, this nascent oxygen from 2 steps. After cancelling the 2 steps, second what we get the overall reaction. This is called what here overall reaction. Overall reaction. So overall reaction is obtained here. Overall reaction is obtained. Okay, the overall reaction is obtained by adding the 2 steps. The first 2 steps will be added by each other to form what now overall, to get overall reaction. So tell me here, O3 and O3, 2 moles of O3, 2 moles of O3, giving rise to here 1 O2 here, 2 O2 here. So totally how many O2? 3 O2. Okay. Now, if you are given this equation, can you say this one elementary reaction? Overall reaction is given to you. Can you say overall reaction given 2O3 gives rise to 3O2 as elementary reaction? No, we cannot say it as what? Elementary reaction. It is one now complex reaction. How you can say this one as complex reaction? Because it is what now here? Combination of how many steps? 2 steps. Combination of how many steps? 2 steps. So it is called what now here? Complex reaction. Complex reaction, right? Let's take the screenshot now. Some reactions will occur in single step, which are now elementary reactions, and some other reactions, some other chemical reactions occur in 2 or more steps. They are called what here? They are called complex reactions. Complex reactions. So complex reactions occur in 2 or more steps. That point keep in mind. And also one more thing, what you have to remember is that one more point, main point, what you have to remember is that in complex reactions, suppose the 3 steps are there in one reaction, not here. Not in this case. Suppose in one the chemical reaction, there are 3 steps. Suppose first step, second step, third step. Okay. Suppose the first step is slow. First step is what now? Slow reaction. And second, third are somewhat fast. All the reactions need not to be taking place at same speed. Remember. So first reaction is slow, second reaction fast, and third step is also fast in that chemical reaction. Now, which is taken as rate determining step? The overall reaction rate, the overall reaction speed can be decided. The rate of reaction, the rate of overall reaction, the rate of overall reaction is nothing but the speed of overall reaction is determined by what? Which step? Tell me. Slowest step or fastest step? The slowest step decides what? Determines what? The speed of reaction. The speed of overall reaction is decided by what? Determined by what? Only slowest step, remember. So the slow step is called generally what? Rate determining step. Just note on that point. In a complex reaction, the slowest SLOWEST, the slowest step is called, in a complex reaction, the slowest step is called rate determining step. Rate, R-A-T-E, rate determining step. In bracket RDS, like short form, RDS. RDS stands for what? Rate determining step. That is slow or fast step. The slowest step is for rate determining step. Is the concept clear? Now, one more thing what you have to understand is that, see now in this complex reaction, in the step one, how many reacting species involved here? How many reacting molecules you can see? One molecule you can see. In first step, how many molecules of ozone you can see? Only one molecule of ozone we can see, right? Now, for this reaction, number of reacting species colliding with each other. The number of reacting species colliding with each other is called molecularity. What we have to say? Molecularity. That step is that for this first step, what is the molecularity of this step? 1. So it is unimolecular reaction. Unimolecular reaction. Why step 1 is called unimolecular here? Because in step 1, only one reacting species is present as reactant. That's why it is what now? Unimolecular species. Now in second step, if you observe, second step, ozone one molecule is there and one atom of nascent oxygen is there. So nascent oxygen is one species and O3 is one species. How many particles? How many species involved here? 2. That's why the second step is what now? Second step is what? Bimolecular step. Bimolecular step. What is the molecularity of second step here? 2. Molecularity is what? 2. The molecularity of a reaction is what? The number of reacting species. The number of reacting species. Okay. Colliding with each other. The number of reacting species colliding with each other in a given step, in a given reaction is called molecularity of that step. Here for the second step, what is the molecularity? How many molecules, how many particles colliding with each other? One particle of ozone, one particle of nascent oxygen. That's why molecularity of the second one is 2. That's why second step is what now? Bimolecular step. Bimolecular reaction. And the first step is what now? Unimolecular step. Unimolecular step it is. Now check it overall reaction. Overall reaction check. How many molecules involved here? 2 molecules involved. How many molecules involved? 2 molecules. 2 molecules involved indicates what? It is bimolecular again. Overall reaction is what again? Bimolecular. 2 molecules are involved here. So O3 and O3. 2 O3. Here O and O got cancelled here while getting what? Overall reaction. Now O2 and 2 O2. Totally how many O2? 3 O2. Is it balanced equation or not? Overall reaction? Balanced equation. 2 into 3, 6. 3 into 2, 6 atoms of oxygen. So it is what now here? Complex reaction. The concept of complex reaction. Complex reactions are the chemical reactions in which 2 or more steps are available. Among those steps, one is what now generally slowest step. The slowest step is called rate determining step. Now in this case, our first step is what? Rate determining step generally. Now here, in which step the highly reactive species is attacking others? Here, highly reactive species, nascent oxygen is obtained. This nascent oxygen, highly reactive species is attacking in which step? Second step. In second step, it is attacking. Attacking means what? It will be highly reactive. Here, the reaction takes place very fast. Wherever the intermediate, the highly energetic intermediate is attacking, that step generally will be fast. So it is generally what a fast step, it is slow step. How to know the fast step and slow step for the given complex reaction? That is only experimentally done. That can be done only experimentally. Only by experiment we can determine which step is slow, which step is fast. That we cannot say directly. So you have to learn some of the examples of complex reactions. From different reference books, we have to learn what? Different complex reactions. In each complex reaction, how many steps are there, and which step is slow, which step is fast. These are all things you have to learn. That all can be understood only by experimentation. Directly, theoretically, we can't understand which is slow step, which is fast step. Is that clear? So once take the screenshot of this. Yeah, it is about what now here? Complex and elementary reactions. Complex reactions and elementary reactions. Now, if you take this complex reaction, which is unimolecular, the step one is unimolecular. In the step one is what now? Unimolecular step. Unimolecular step it is, or unimolecular reaction. First step. Right now. Now in second step, tell me. In second step, how many molecules, how many species involved here? Two species involved. When two species are involved, it must be taken as bimolecular. Bimolecular. It should be what now here? Bimolecular. What is the molecularity? 2. So bimolecular step or bimolecular reaction. Now what is the molecularity here? What is the molecularity? Molecularity is what 2 here. Is that clear, man? For this step, what is the molecularity? Molecularity of this step is what? Step 1 is what? 1. So molecularity is nothing but the number of reacting species. The number of reacting species that attack each other. Okay, to give what now products. It's called what now? Molecularity. Here bimolecular, it is unimolecular. Now overall reaction also what again? Bimolecular we can say. Now what we have to understand is that now just reverse this equation. This given equation, if you reverse, what we get on reversing this equation, overall reaction 3O2 gives rise to 2O3. Okay, so on reversing what we are getting here, tell me. On reversing the overall reaction we get 3O2 gives rise to what now? 2O3. 3O2 gives rise to 2O3. Okay. Now in this case, now how many molecules, how many reactant species, interacting with each other here? 3 molecules. So now what is the molecularity here? 3. Molecularity 3 indicates what? It is termolecular. Ter means 3. Ter indicates what now? 3. Bimolecular reactions, unimolecular reactions, molecular reactions. Don't say tri. Generally, tri we don't use here. Ter we have said. Molecular species. So this reaction, the reverse of this one here. This overall reaction is reverse. The overall reaction is reverse. On reversing this overall reaction, we got this one here. 3O2 gives rise to 2O3. 3O2 gives rise to 2O3. Now in this case, how many reacting species there, ma'am? 3. How many reacting species? 3O2 there. O2 plus O2 plus O2. 3O2 there. That's why what is the molecularity here? 3. Molecularity 3 indicates what? Molecular reaction. This is one here. Molecular reaction. Molecular reaction. Molecular reaction. That means what is the molecularity here? Molecularity is what? 3. Molecularity is 3. And stay a molecularity reaction is what? The reaction with molecularity 3. The reactions with the molecularity 3 are called what? Molecular reactions. So we can classify the reactions into 3 types generally. What are they? Unimolecular, bimolecular, termolecular. Okay. And more than quaternary, all these will not be generally possible. At a time, how many molecules can collide with each other in 3 dimensions? 3. Along x-axis, y-axis, z-axis, maximum 3 molecules can collide with each other simultaneously. So the number of reacting species colliding with each other simultaneously in the given step is called what? molecularity. So how many molecules at a time can collide with each other? Maximum possibility 3 molecules. So unimolecular with molecularity 1. Bimolecular reactions with molecularity 2. 10 molecular reactions with molecularity 3. The clear? So it's about molecularity of reaction. Molecularity of reaction is nothing but the number of reacting species colliding with each other simultaneously in a given reaction or in a given step. Is that clear? So now in this case, in case of complex reaction, do all the steps have same molecularity? No. Here, step 1 is unimolecular. Step 2 is bimolecular. So all the steps in a complex reaction need not to be what? Having same molecularity. They cannot have all molecularity or same molecularity. Is it clear now? So now we have understood that the chemical reactions are classified into how many types? 2 types. What are the elementary reactions and complex reactions? Elementary reactions occur in single step and complete in 1 step. And complex reactions occur in 2 or more steps. Next thing, the classification of chemical reactions based on rate of reaction also we have to study. Very fast reactions complete in 10 to the power of minus 16 to 10 to the power of minus 14 seconds. Very slow reactions are completed in some months together will be taken for the completion of very slow reactions. And very means the moderate reactions are there. Moderate reactions are neither very fast nor very slow. That type of reactions take some hours, few hours. In few hours, the reaction will be completed. That such reactions are called what? Molecular means what? Moderate reactions. Most of the reactions come under which category? Moderate reactions. Moderate reactions. So this concept is about what now? Classification of chemical reactions based on rate and based on number of steps. Is that clear? So now for the complex reactions, we study what? We need to study what? The mechanism of reaction. Mechanism of reaction means what? The path of chemical reaction. Path of chemical reaction. Okay, mechanism of reaction or path of chemical reaction. Is that clear? So far we have discussed about the concepts such as what? Rate of reaction. Okay, and average rate of reaction and instantaneous rate of reaction. Along with the classification of types of reactions, means along with the types of chemical reactions, we have studied about rate of reaction, average rate of reaction, and instantaneous rate of reaction. Generally, what is the rate of reaction? When there is a change in concentration of reactant or in the concentration of product with time, that is called what now? Rate of reaction. The change in concentration of reactant or in the concentration of product with time is called what? Rate of reaction. Next, what is average rate of reaction? If the time interval is large, T2 minus T1, the final time minus initial time. If time interval is large, in that case we use the word average rate of reaction. When time interval is large, T2 minus T1 value, if it is large, if delta T value is large, then the concentration difference also will be more than final concentration of reactant minus initial concentration of reactant. This difference in concentration also will be large. In that case, we use which name? Average rate of reaction, we say. Average rate of reaction. That means what now here? If you are moving in a car from your house to office, suppose, from house to home. If you are moving from one place to other place, what happens now here? Sometimes car will be moving fast, sometimes car is moving slowly. Okay, now the total distance we take here from this point to this point, how much distance the car has traveled. This is total distance traveled here. Is that clear? Sometimes reaction is fast, sometimes reaction is slow. Now time taken is suppose t seconds or t time is taken here. Now for the distance is what now here? This much distance is traveling t seconds time suppose. Now how to take average rate of reaction? The distance, the total distance traveled by time taken. That is average rate, average speed of the car. Average speed of the car. But car is not moving with that average speed now always. Sometimes it is moving slowly, sometimes the car is moving fast. The same way, the chemical reaction also, when reactants are getting converted into product, the chemical reactions also take place slowly sometimes, fast sometimes. Is that clear? That is not uniform. The rate of reaction is not uniform. That's why we use what now generally average rate. Average rate of reaction. Average rate of reaction is equal to what? Final concentration of reactant minus initial concentration of reactant divided by final time minus initial time. Is that clear? The same thing we can apply. Average rate is equal to final concentration of product minus initial concentration of product divided by final time taken minus initial time taken. So this is what now here, the average rate of reaction. Then what is the instantaneous rate of reaction? Instantaneous rate of reaction. If time interval is very small, if time interval T2 minus T1, final time minus initial time, if it is infinitesimally small, if it is very small, in that case, what we use the rate here? Instantaneous rate means the rate of a reaction measured over a small interval of time. Okay, the rate of a reaction measured over a small interval of time, infinitesimally small interval of time is called instantaneous rate of reaction. And what is average rate of reaction? The rate of reaction measured over a very long time interval. A large time interval is used there in average reaction. The rate of reaction measured over a large interval of time. A large time interval is called what? Average rate of reaction. So we studied about average rate of reaction, instantaneous rate of reaction at a particular time exactly, then types of reactions, and also we discussed about what? The concept of molecularity. Molecularity. And next we are going to discuss about what? Order of reaction. OR-DER. OR-DER. Order of reaction. Generally, these two are very important concepts here. Molecularity and order of reaction in this chemical kinetics. So we have started discussion of what? Molecularity, and we are going to discuss about what next? Order of reaction. OR-DER. Order of reaction. Is that clear, ma'am? In the next class, we are going to study about order of reaction. Okay.